All right, so today what we're talking about are strategies for word problems, or as we were kind of talking in the reading, situations. So here we're talking about conditional probability. And typically what I like to talk to my kids about first is what conditional probability is. It's this idea that, hey, if you have a drink and popcorn in your hands, what's the likelihood that you're at the movies given you have both these things? Now, just because you have, I don't know, like a soda and popcorn in your hand doesn't necessarily mean you're at the movies. Or for instance, if you have suntan lotion and bathing suit, what's the probability that you're already at the beach? Just because you have suntan lotion and your bathing suit doesn't mean that you're necessarily at the beach, but I mean, you could be in a lot of beach-like places. So it's about what the percentage of this already happening given that something has already happened. So in this situation, we're going to look at this probability. So first I have them read it out and say, hey, the probability of ordering a sandwich given that you ate chips is 0.51. The probability of ordering a sandwich is 0.32. And the probability of eating chips is 0.24. Is eating chips independent of ordering a sandwich? Now, at this point, we've already talked about independent and dependent, which are basically things that affect each other or do not affect each other. Independent meaning, hey, it's two things that will not affect. Dependent means one obviously affects the other. So in this situation, if you're eating chips, well, does that mean you had a sandwich already? So is eating chips independent of ordering a sandwich? Like just because you eat a sandwich doesn't mean you necessarily have chips. Just because you have chips doesn't necessarily mean you had a sandwich. Unless there's something like, I don't know, some kind of deal where they give you chips and a sandwich. So what I tell my kids to do is look for four different things. First, we have to find four pieces in this situation. We have to find the probability of A, the probability of B, the probability of A and B. That's what the little upside down horseshoe or that end looking thing, that means the word and. Last part is the probability of A given B. And this line here, I know it looks like a slash, it's dividing. It's not, it means given. The probability of A given that B has already happened. Then I tell my students, like, hey, word search for the word given. And then I might get some of my students that say, oh, here it is. Here's the given right here. And I tell them to circle that. That's your starting point. Then I tell them, hey, look to your left. What do we see? We say, hey, the probability of ordering a sandwich. Well, that means your A is going to be a sandwich. So we'll put that right here. So the probability A is our sandwich. Then we start back at this given. We look to the right. And we see chips. Chips is going to be your B. So we found our A and our B, sandwich and chips. Then if we look back at it, the probability of ordering a sandwich given that you ate chips is 0.51. Hey, probability of A given B, well, that's where we're going to put our given, which is 0.51. Now, in this situation, what we have to do is kind of look back through and find the word sandwich and see if there's a number attached to it. And then students will go through and the probability of ordering a sandwich is 0.32. So our probability A is 0.32. Then they'll look through and say, hey, eating chips, which is our B, and we can even put our B here and our A over here, chips is going to be 0.24. Well, now that we have sandwich and chips, we can find the probability of A and B because we literally have A and B here. So it would be 0.32 times 0.24. Whenever we use the word and, that means to multiply. So now that we have all four pieces, we're going to plug them into this equation. I'm going to write it out. It's the probability of A, given that B has already happened, is equal to the probability of A and B divided by the probability of B. Now, all we're going to do in this situation is plug in the stuff that we have. For instance, the probability of A given B. Oh, we have that right here. So instead of writing this, we're just going to plug in this number and turn it into 0.51 equals, well, we have the probability of A and B. It's right here, the probability of A and B, or we can think about it as A and B. So it's just going to be 0.32 times 0.24 divided by the probability of B. We already have the probability of B in several places. We have it here and we have it here. So it's just going to be 0.24. So at this point, I tell students, hey, look on the side here. Look on the left side of the equal sign. Well, nothing's really happening here, so we could just drop this one down. Nothing happening there. On the right side, what they can do here is that they can either put this in your calculator, or if they're smarter, they can start to realize, hey, we got 0.24 on the top and bottom being multiplied, so these can actually cancel out. Then we could drop down this 0.32. So at this point then, we have the statement which is 0.51 equals to 0.32. And most will kind of say, hey, well, this does not equal to this. These are not the same number. So this is kind of impossible. So either we actually put a slash here that means not equals, because these are not the same number. So if it's not equals, it is dependent. Meaning that in this case and scenario is that if you ordered chips or ordered a sandwich, you're probably going to have one or the other. They're probably part of a combination deal. And that'd be the answer and how we're trying to find this conditional probability in these situations.